In this video, we're going to further discuss the double displacement or double replacement reactions that were introduced in the last video. So these are also referred to as metathesis or exchange reactions. The term metathesis comes from the Greek word which means to transpose, and that means switching when we talk about ions here specifically. So say I have ionic compound, which has the cation A and ion B, and then I react that with another ionic compound in solution that has the formula CD. So what we're going to see is that the cation A would then be transposed or mixed, switched with, instead of B, now we see D, and then we'll have C and B. So the partners that we saw over here, so A was partnered with B, is now going to partner with D, and B was partnered with A, is now going to partner with C. So we've transposed our ions. So that's where that terminology comes from. Let's take a look at sample exercise 3 here, where we're told that a solid, a precipitate, will form when aqueous solutions, so we have barium chloride dissolved in water and potassium sulfate. So when we mix these two solutions, we're going to form a precipitate. So what we should think is what happens when we mix together aqueous barium chloride and K2SO4, also aqueous. What solid could we get? So we're going to switch partners here, and I could mix together barium with sulfate. So Ba2 plus and SO4 2 negative would combine, and I'll check my table on the previous page to see if that would form a precipitate. But then I'm also going to mix together potassium and chloride. Notice that I have 2 and 2, so that makes me think that I'll probably need 2 of each of those. I still don't know if it's solid or aqueous yet. But then for every 1 barium, I only have 1 sulfate over here, so it looks like that's already balanced. So I just need to add that coefficient 2 here. So we're asked specifically to write the balanced chemical equation, so we've made sure to do that so far. Now let's go up to that table from the previous video that we used here, and I'll try to write over the markings from before. Notice that barium, oh, down here, barium is one of those exceptions for hydroxide. Oh, it's actually up here that I'm looking for my exception, because I don't want to make an insoluble exception. I want to know if I'm going to get a precipitate. So barium, oh, is one of the times when sulfate will form a solid precipitate. And then we can see that chloride, that's always going to be soluble unless we have these ions here. So with potassium in our other potential product that we wrote below, we know that that would remain aqueous. So let's go back and add those notations here. So barium sulfate, we've determined would be our precipitate. Potassium chloride would remain aqueous. So this is the balanced chemical equation for the reaction between aqueous barium chloride and aqueous potassium sulfate. So our product, again, the precipitate would be here. So we're asked to identify the precipitate. So that's it for sample exercise 3. But let's walk through a little bit further. So say we were asked to write our aqueous, or I'm sorry, our molecular equation for a reaction of 2 aqueous solutions. So say we have silver nitrate, so AgNO3, written as a molecule, but indicated as aqueous. So we've written it together, we didn't ionize. So that's what the molecular equation is asking us to do. So say we mix this silver nitrate with potassium chloride. Both of these are aqueous solutions, and then we're asked to predict what products could form. So this is the molecular equation, but then the ionic equation, what I'm going to do is I'm going to break down Ag plus aqueous, and then NO3 negative, also aqueous. And then I'll break down, okay, I have 1 of each K plus aqueous, and I also have a chloride, Cl negative aqueous. So if I was to crisscross these ions, I would pair the silver with the chloride and the nitrate with the potassium. So after I double check my list above, I would see that potassium nitrate will remain aqueous. And then when I combine silver and chloride together, I would end up with a precipitate. So when I write the ionic equation, I would keep the potassium as an ion over here and the nitrate as an ion as well. But I would match up or pair together my silver with my chloride ions. So what we can see happens here is that we could cancel out everything that remains in solution on both the product and the reactant side, and then we could just write out what's called our net ionic equation here, which would show my silver ions aqueous and my chloride ions aqueous on this side of the reaction, and we form our silver chloride precipitate on the product side. So we'll continue with more examples of this in the next video.